Alright everyone, welcome back to Cody'sLab. So today I'm going to turn this gold bar into a solid 24 karat gold bullet, and then I'm going to shoot it. So here's the mold I'm going to use. I started off with a regular lead Minié ball, then I poured some refractory cement around it. And now I'm just going to melt the lead so that it runs out of the mold, leaving a cavity in the exact shape of the bullet. So let's put it in the furnace and see if it works. Just 1 ounce of gold is probably not enough, and so I'm going to add this other piece of gold here, which came from some stuff that I refined. It's also pure gold, so there you go. That brings our total gold up to about 2 troy ounces. Okay, we're at temperature. Let's pull the mold and the gold out of the furnace. And here's the gold. Set that there for just a second. I'm going to pour in the gold. There it is. Hopefully that worked. Alright, here it is after cooling off for a little while. It's still quite warm, but I'm kind of excited to crack it open and see how it looks. There it is. Trying to save the mold. I doubt I will. Oh yeah, it ruined it. Alright, there it is. Looks like a successful cast to me. Let's continue cleaning it up. Ah, it's got a little bit of a pocket in the side right there. But overall, I think it worked. Now I'm going to cut this top part off to make it into a fireable bullet. And to do that, I'm just going to use these nippers and a vise to cut the gold. The gold's pretty soft, so this is pretty doable. There it is. Just repeat that a couple of times, and we're good. Now for some fine tuning with a rasp. Well, there it is. It's got a few bubbles in the side of it, but it's in a general bullet shape, and I think it will work. Looks pretty nice. I think the dimples on the side actually make it look kind of like a gold nugget, which it is. Alright, let's see how much the lead bullet weighs. Looks like 24 grams, and the gold bullet is 38 grams, so quite a bit heavier, even though it's the same size and full of little pits. It's just because gold is so dense. Alright, let's go shoot them. I got a new chronograph, and I'm going to shoot the bullet through that into a ring of paper. This will tell us how fast it is, and we can compare it to the gold. 3, 2, 1. On target. 872 feet per second. Sounds about right. Now, let's load the gold and see how it turns out. So, 50 grains of powder once again. So here's our gold bullet. I'm going to put a little bit of oil on it to lube it. Here we go. Alright, gold's loaded. Here it goes. Put it in the primer. This bullet's worth more than the gun. Alright, let's see how many sheets of paper it goes through. Alright, in 3, 2, 1. Oh, that kicked a little harder. Did it go right through the block?
I hope not.
Well, it looks like the lead bullet didn't go through the first ream. Look at that. Yeah, the lead flattened out. Totally deformed it. and stopped immediately. The gold went all the way through the ream of paper. Looks like halfway through the second one. There it is, all mushroomed over. You see it took a little bit of the riflings. It's still warm. And it kind of looks to me like a piece of it broke off. See that? Is it in there farther? Yeah, it is. It's right there. So it broke apart after it hit the paper. Didn't actually do that in the gun. Yeah, see them. And it appears to have a bit more penetrating power than lead. Sort of makes sense because it weighs more. Hey, how fast did it go? It even went a little faster. How about that? So since the first number was so low, I think I'm going to try the lead again. Since it was the first shot of the day, perhaps the barrel had a little bit less lubricant on it and the shot was, not as fast. So let's try the lead one more time, just to see. Because I think the lead should have gone a bit faster. Firing in 3, 2, 1. Yeah, still 890. So the gold did go faster. So there's the lead bullet we just fired. This is the gold bullet. And there's the first lead bullet. So they're all about the same speed. And just a bunch of little bits of gold powder. Yeah, so there's what's left. Bunch of pieces of the lead. The lead just pancaked out when it hit the paper. The gold stayed together mostly, as you'd expect from a little bit harder metal. And looks like some pieces of the gold broke off. It looks like I can recover most of it. Let's put the gold back on a scale and see just how much I was able to recover. There's a bunch of little pieces here. Yeah, so it looks like most of it. There are some other little bits of dust that I just mixed in with the filings here, but there you go. I didn't really lose much of it. Now that I've got a little bit better lighting, let's have a closer look at this bullet. You can see there's some riflings just barely in it. It really didn't dig into the riflings all that much. I kind of expected that. Since the gold is harder, the back of it didn't flare out as much and didn't hug the barrel as tightly. But it obviously still worked. And I think the reason why the gold broke up is because, especially down here towards the bottom of the bullet, it cooled very slowly, so the gold had a lot of time to crystallize. I think it would be better to start with a solid piece of, say, extruded rod and then machine the bullet, but I didn't really have the capability of doing that. So there's a few reasons why we use lead for bullets. First of all, lead is a fairly dense material, which means it has a high mass to cross-sectional area, so that it's more easily able to punch through things such as the air or flesh. When it impacts something, there's a lot of weight right behind it over a small spot, so it creates a lot of pressure. Second, lead is a soft material, and so when it hits the target, it'll deform, spreading out and dropping all of its energy all at once. You see, it's not the piercing of the animal that kills it, it's the shock. And lead is soft enough that just a flat, blunt-pointed bullet is enough to get it to spread out very quickly. Gold definitely has the density thing down, being nearly twice as dense as lead, so it's able to punch through the air or whatever without losing as much energy. But of course, gold is a little bit harder than lead, so it didn't come apart, it didn't spread out and deliver its energy as soon as it hit the target. But I think you could solve that problem by giving it a hollow point rather than a blunt tip. But the main reason we use lead is because it's cheap. Gold is not cheap. In fact, this little chunk of metal has a fair market value of like $1,500, which is just crazy. I think what surprised me most about this experiment is that I measured the speed of the gold to be about the same, if not just a little bit more, than the speed of the lead bullet. Now, for a given speed, this is going to have a lot more momentum because it has more mass. By having more mass means it has more inertia, and when it hits a target, it's going to be a lot harder to stop. It's going to have more energy. But that also means that it's harder to get going. I think there's two main reasons for this result. First of all, the gold bullet, since it didn't expand and fit the barrel as tightly, you didn't have as much friction in the barrel, like it wasn't grabbing into riflings as hard, which means it wasn't spinning as fast. Less of its energy went into spinning. But I don't think that accounts for all of it. You see, there's only so fast that a given amount of gunpowder can push something out of the gun. I think even if the bullet was made out of something lighter, say wood, it would have wound up around the same velocity. Because as the gases expand, they cool, and they have to fill up the barrel of the gun. But also, there's the speed of sound issues, which I've talked about in another video, the pellet gun and helium. But basically, the gun would shoot the object the same speed no matter what, which means if you got a heavier object, it's a more efficient use of your gunpowder. Now, if I would use more gunpowder, say the 65 to 70 grains of gunpowder that's actually recommended for that rifle, then the lead bullet would have continued to be accelerated all the way to the end of the barrel, and the gold bullet might not have actually obtained the full velocity before leaving the barrel. So, there you go. I definitely want to try shooting gold with a more modern gun, say something that is already designed to shoot bullets made out of brass. But of course for that I might have to have somebody machine the bullet for me. Anyway, hope you all enjoyed. I'll see you next time.